let me just set the stage real quick. I'm the founder and CEO of ElectricSQL. So today we can store data in our browser and we can run any code in the browser with WASM. Now you come in and say with PG Lite, you can run a Postgres database in your browser. And with Electric, you can build local first applications and sync your Postgres.
That's right.
All right.
It is pretty crazy what you can run in the database. PG Lite is
We really like to hear, why local first, why sync, why now, what are the things we can make with this? And then if you'd like to actually give us a demo and a walkthrough of the platform as well. Awesome.
and great, what we're developing. With this very constrained environment. System capabilities of the network, it's actually viable to move hundreds of gigabytes of data on local device. Of different projects to do what's possible in San Francisco or the organized. And you can load a huge amount of data into it extremely fast and just do fast analytics on the device. Kind of like imagine it's manage syncing in interaction by do all of the matching and coding across the network. On the sync side, it is kind of that.
Very excited to see like all the new
Sorry,
applications that
yeah.
people build with this. I mean, I understand there's the offline mode, right? Maybe some people are familiar from linear, and then there's collaboration, real time, things happening in front of you. That's snappiness, that's speed that we want in new
Yeah.
applications. But also this unlocks some new use cases with local AI. Is this something that you guys see as a major use case for Electric?
Apps kind of that feel super snap, making smarter, and you have things like search, or you have AI models. Workflow, the data, of being able to run AI locally is really powerful. Putting a huge amount of effort into making, say, acute need. If you're interacting with, have a lag, otherwise it feels like old-fashioned satellite. Data spend all this time kind of coding. Sort of local first applications demo the data, and the data is just there, like you instant. So there's step, and so that's where sync is, that you have the data basically keep, and if you have that, so you can in there instant, everything works offline. X. I think these are some of the reasons why whether you're building an application or fresh is the way in the future.
The proposition is definitely very, very compelling. And, I'd love to even later dig into the nitty gritty when it comes to developing with it. I mean, ourselves using Postgres, we have something like Drizzle as an ORM, and we care about type safety of turning, making endpoints out of our queries. So we'd love to like get into these details. But, if you could maybe share your screen and give us a walkthrough, possibly a short demo, and we can get to this point later. Cool.
Yeah. The electric website.
This thanks to okay. So
Does that come through to you okay from my side?
yep. Let us just crop it out properly.
Cool.
Okay, I don't know what to do about it on the stream. Do we need this? We need it. This is where he speaks from. It happened last time as well. It's the same issue. I don't know what to do about it. James, give us a quick minute because we have a little bit of an issue with your sound on our end.
Okay.
Yeah. Should I put BRB? No. Okay. So, and then would you need to take this down on the stream?
Okay, after the very short break, we're ready to continue the demo. Very sorry. You're good to go, James.
Hey, awesome. Yeah, so I'll just kind of, I guess, introduce you a bit to the electric kind of project and some of the kind of aspects that we're working on. And I can maybe fire up a couple of demos and then also dive into particularly PG Lite, which is this lightweight WASM Postgres project, and show you some of the apps that are built on that and kind of how it fits in with electric.
Perfect.
So we're ElectricSQL. We're basically a Postgres sync engine. And as you can see up front, right, it's kind of going, why would you write all this code to go and do this sort of manual data fetching and loading and code across the network when you could just sync? And it all starts with Postgres, right? So for us, Postgres is just one of the most popular databases. It's a tool that just lots of people are building systems on. So it's kind of where your data is at the moment. And so instead of having to say have some separate sync system or separate kind of real-time infrastructure, what if you could just have your data in Postgres, just describe where else you want it to be, and you have these little subsets or copies of your data wherever you need it, in the web browser, mobile app, backend services, workers, etc. And you get this little subset of data there, and it's just kept magically in sync for you. And so that's what we do. And so we have the sync engine, which basically syncs little subsets out of Postgres into kind of wherever you need it. And technically what that does is you have Postgres. Postgres provides logical replication, which is a way of like consuming the change feed out of the database. And we kind of fan that out to clients via a primitive that we call a shape. And so a shape is a shape is like a kind of little part of your data. And you can imagine, like I was talking about that Figma example before. So imagine that you had like a design document, and it could be all the data that lives within that document. Or imagine if you're creating a project management tool, you might have like a workspace or a project, and that might contain documents and issues and comments or something. And so it's a way of sort of just grabbing a set of related data and saying, hey, that's what I want to kind of sync over here. So that's kind of like that's basically the sync engine, and then it's based on Postgres, and it only works out of Postgres, but you can sync into a whole variety of different clients. So you could sync into a JavaScript object is like the simplest thing you can do, or you can sync into a variety of different stores or client-side things. You could sync to a Redis cache, all the way over here to PG Lite. So PG Lite is our lightweight WASM Postgres build. So it's basically full Postgres run in single user mode, compiled to run natively in WASM. And so it runs in any JavaScript environment. And so that's an example of like an embedded database that you can have inside a local application that you then sync into with Electric. And then at the moment we're working on building a cloud product, which is like, so Electric is open source code. Here it is on GitHub. It's Apache 2, it's an Elixir web service. You can just fire it up and run it yourself. And we provide a bunch of kind of packaging and quick start stuff, but we're also building a hosted Electric. And one of the nice things, as you'll see, is that the sync service is built on an HTTP protocol, which allows us to leverage CDN infrastructure to accelerate and scale out the sync. And that's going to be nice and tightly integrated in with the cloud offering once we build it. I mean, just to sort of give you a very sort of quick example, like what's the simplest way of using Electric? So say you have an existing application and you have like a page or a route and you're doing a data fetch. Well, you could come along and just replace that with sync. And so kind of this, just like a couple of lines here, data is a React state variable. This is a use shape hook that we provide. You have a URL that just defines the data that you want to sync into the application. Just kept in sync for you. And so you could basically start using Electric in an existing app today, just replacing it out one route at a time. Or if you want to move more into a kind of fuller local first paradigm with an embedded, in this case, PG Lite database, here's the example code to do that. So you basically create a instance of the Postgres database inside the web browser. Here we just like set up a basic schema, create an items table. We have a few primitives for sync. So this one is basically syncing a shape into a table. And in this case, like the item shape into the items table. And then what's really nice is you have this thing where you sync the data into the local data store, but then your components can bind live queries to that local database. And so whenever the data changes, either because you've changed it or because it's synced in from somewhere else, the state updates in your application and things just automatically re-render. And you get this slight separation between synchronizing the data into the local device or store from actually binding the data to the components. So you can have many components which are all to the same data, but it's kind of normalized into this local embedded database through this kind of live query primitive. So in this case, it's just you can write any SQL you like, that's against a local Postgres database, and whenever the results of that query change, they're reflected in the items, which is a React state variable, and then that just renders. So I hope that gives you a sense of it. Like if you wanted to just follow along and kind of run Electric, so this is electricsql.com, this is our quick start, we can just process of running in a few steps and then using the low-level HTTP protocol that we use for sync, and then it steps it up to running a JavaScript application using some slightly more convenient client primitives that we provide. But if you like, we could just kind of like follow along here just to get a sense of it. So, for example, if I just go into a folder here and then I make this my first Electric folder, I'm just going to cd into it so we have like a working directory. And then here we have a Docker Compose file that is basically just Postgres and Electric, which is packaged using Docker, and they're just connected together. So it's just a simple way of running Postgres and Electric connected together. You can run Electric against an existing Postgres, and that's kind of encouraged, but this is a simple way of getting started. So if I just grab that Docker Compose file and then run it, that basically runs the Postgres and Electric services. Maybe I think I was just running one already. Let me just double check my Docker. Let me just wipe stuff. I think I just had a clash with a demo app that I was just preparing before to show you. So that's why the quick start just had a namespace clash. Gotta love live demos. So if we just wipe everything, just try that again. So now I'm just grabbing down the Electric and Postgres layers, won't take too long. Maybe I should have just killed the services instead. So basically this is going to come down and just run the services. If we come back then to the quick start, what we then get is we get the ability to just call the Electric service on the HTTP API, and it's just a standard. You basically replicate data out of Postgres just using a standard. So this stuff's all kind of working now. That's nice. So to in here, for instance, I run this. Now, actually, this is designed to fail. It's a bad request because it's requesting data that we haven't actually created into the Postgres yet. So, but before we just dive into doing that, let me just explain the URL structure. So you basically say, hey, I want to get the data in a shape. In this case, it's saying I want the food data from the food table. You can filter the data with where clauses, etc. And then the offset basically says start at the beginning. And so, yeah, we get this kind of request that we're expected. Now what I can do is just hop into that Postgres, which is running here, and I will run this code to create the food table. And then let's just insert some example data so that we can see it. And now if we come out of the PSQL command and we run that curl command again, we'll basically get a bunch of data through. And as you can see, it comes through as like an array of JSON objects, and there's a bunch of stuff around offsets and things in the kind of headers. So that's basically what you're seeing here is that where we inserted that data into the Postgres database, that comes through as like a log of logical operations in this replication stream. And that's what you're sort of getting in that kind of array here. And then if you were doing something like building your own client integration or you could keep basically working with this low-level HTTP API. Like with the HTTP API, there is a open API spec here, for example. It's very simple. There's just these two main endpoints that allow you to just consume the data with a few parameters. But going back to the quick start, if we just want to move up to a slightly higher level of abstraction, we can create a React application. So if I grab this here, this is just going to use just standard React boilerplate, and we can come through and we can go, okay, let's go into this new React app subfolder that we just created, and we're just going to install ElectricSQL as a dependency from npm. And then in this sort of, it's just the standard React app boilerplate, and we're basically just going to replace the main app code that they create with a component here that uses that example that we were using before. So you subscribe to a shape URL and then it just renders the data. And so if I just have a look at the source code here, this is the contents of this TSX at the moment. And if I just paste this instead to use ElectricSQL to render a component, we can then come along, run the dev server to run the app. And then if we open up where are we? We just go to the URL, we get this very, very basic output because we've just generated a trivial app that just JSON renders the data. But one of the nice things that you can immediately see here is how, for example, if I then go back to accessing the Postgres, we can have a look at the data model that's just in this app. It's this foo table, right? So if we go select all from foo, these are the items that are in there at the moment. And what I can do is, if I say grab one of these, so the foo whose ID 2 at the moment is called Bob, and let's say I update it to James, then you can just see that it updated live in the browser. And so you get this really nice kind of workflow where you basically, any changes that are written into a central Postgres just immediately stream out through this partial replication primitive in the client. And it's all just live bindings where you can write any component you like. And in this case, it just uses a shape. Or if we switched it up to use like a local embedded database, then you have this sort of live query abstraction. Maybe one thing I thought, let me just check. Any questions or anything on this? Or I was just going to switch into a slightly more realistic demo of a linear clone that's built on Electric.
So far, so good. This has been great, and definitely super excited to look at the demo. Yeah.
Okay, cool. So just stopping these containers. There we go. I think what I'm going to do is down volumes just to make sure it kills the data. So what we have, so inside the main repo, so like this is the source code for Electric. There's an examples folder, and we've got a bunch of different examples in here. One of them is Linear Lite, which is like a clone of the Linear project management system. So Linear is one of the projects that's pioneered this kind of sync engine architecture, and they built a very nice kind of system themselves to sort of manage how they sync data into the Linear application to make it feel super fast. And so what's nice is then just to be able to kind of show how you can achieve that with Electric as a sort of general sync engine component that anybody can switch into their app to build on a similar architecture. So if we go into that, and then let's just have a look at the README. So I've already installed the dependencies just in the root of the monorepo. We can just come here again and do a similar thing to those backend services. May just have to pull down the images. And then we're just going to run the dev server, and again, we'll have the application in the browser. And so it's just the same URL. And there it is, right? It's just sort of synthetic data. But one of the things that's nice is you can just get a sense of like how quick the app feels. If we have if we have a look under the hood, for example, so here, at the moment I have the cache disabled. But basically on this page, like there's a couple of URLs here, which are just HTTP requests to that kind of shape URL that we were looking at before, making curl requests to. And you can kind of, in this case, it's just like syncing the data for a particular issue or a comment. If we go to like all issues, then you can see that here it's just basically syncing like all of the issues in. The timing on it is, let's just come out of this. So it's like, it's 323 kilobytes worth of data. It syncs in 20 milliseconds. And that's basically direct from the Electric server, which is talking to Postgres. There's no caching on this, and there's no caching yet in the browser. Like if I don't disable the cache and I come in, it's just like everything's just instant. The data's just immediately there. And so like you can just sort of get a sense of just this sort of feel for like as you come along and like kind of filter the data, everything's just instant. And if you sort of change state and kind of come back to it and you interact with stuff, like everything is instant and all the data is kind of still there. So there's no loading spinners. This is how a kind of modern application should feel in terms of performance. Maybe then just to give you a sort of sense, like what we have is we have some higher level TypeScript clients, which we used in that React application. So you get like a shape stream primitive for consuming the log, and then you can basically materialize the shape stream into a shape class. It's quite simple to write your own client for other languages. Here, for instance, is this use shape hook for the React integration. Again, it's actually very simple to do the little bit of shim to kind of connect to shape, which provides like notifications when things change to like map that to state variables or signals for like different frameworks, so kind of Vue, Solid, etc. And a lot of people in the community have built those out. In terms of kind of use cases for this, you have the sort of main thing of just basically going, well, why do you have all these APIs and data fetching and network error codes and just doing this kind of replacing all that manual data fetching with data synchronization? Obviously, it's good for building local first software that works offline, because it can be like Electric is the sync component of a local first stack. Like local first software, you sort of then so need like the client side component and the kind of reactivity model. And there's some very cool other projects in the local first space that are sort of building different parts of the stack. Like for example, Live Store is being built as a sort of very optimal client side that works well with Electric as a sync layer. You can also use Electric as just a way of maintaining caches. So if you think about like how you do caches at the moment, you'll have like some maybe hot path of your. The trouble with the cache is how do you keep it up to date, or how do you invalidate the content? And basically that's just what Electric does automatically for you. So like here, for example, like this is an example of using Electric to maintain a Redis cache. And it basically just solves, like it consumes that shape stream here, and then it just like updates the cache for you. And so with a little bit of just, this is just like a few lines of code as a kind of manual integration, you can integrate this like HTTP stream into pretty much anything that you want. And in this case, you can just have caches with automatic cache invalidation, instead of having to have some sort of TTL or expiry strategy, and you end up with stale data, and then you start getting consistency errors, and you sort of go down that distributed systems rabbit when you speed your application up. Another kind of nice application that we sort of touched on before is like applications that are adding AI models. And then particularly with RAG, you have this workflow where you need to tap into existing data to provide context data for the model when running this kind of retrieval augmented generation. And so what you can do with Electric is basically use it as a system to sync in the data for that local knowledge base, for particularly when you have an AI that's like on a server in a mobile app in the browser. What's nice is you can use these shape primitives to control the shape of that local knowledge base. So you can kind of control what data is available to that particular like personalized AI. So you could sync again like the data that a user has access to be able to augment the intelligence of the AI systems that they're working with. And we've done some nice projects on this where we've done like very nice low latency AI inference working with information. And one of the apps I'll just show in a sec is a really nice application that Supabase have built on PG Lite, where they built like an AI powered kind of database driven application builder. So I hope that gives you a bit of sense of kind of Electric. I mean, they're maybe just sort of jumping into kind of PG Lite here. So PG Lite is basically Postgres. It's like a build of Postgres, but what it's done is it uses Nscripton to compile it to WASM, and so that means it can run in any environment that supports WASM, including JavaScript-based environments like the browser, Node, Bun, Deno. So you have like browser-based applications, but you also have, say, like Supabase edge workers run on Deno, for example. And there's a lot of applications where you're running, say, backend services using Node, and if those are database backed, instead of having to spin up your own database service, actually you can just embed, like it's an npm install, and you can just embed Postgres in the process of the application. So this is like the example code here, which is just like you literally import PG Lite, and then you instantiate it, and then you have a fully featured database available in the browser. One of the tricks is that it runs Postgres in something called single user mode. So Postgres is like has kind of multi-user concurrency, but it had this debug mode for single user access built into it. So basically kind of support admins debugging the database back in the day. And Stas, the CTO at Neon, which is one of the serverless database services, did some very cool experiments to being able to use Postgres in single user mode to make a smaller native WASM build. And so we basically inherited those experiments and have been building it out into a production grade system. And now there's a whole bunch of cool stuff, like we have a dynamic extension loading mechanism. So you can run, for example, PG Vector inside the database. You can run like PostGIS. There's about 30 extensions which are now supported. And then with Electric, you can basically use Electric to sync data into PG Lite. So like the example that we were looking at before. So if we kind of jump over to it, this is the PG Lite project. Again, it's like Apache 2 or Postgres license on GitHub. It's a lightweight WASM build of Postgres. It has like this extensions catalog, so you can compile in like for example PG Vector. So if you want to build AI applications where you build sort of settings, you can have a relational data model where you have like a hybrid vector relational data that's synced between Postgres in the cloud, and then a subset of that synced into a local application. And then we provide some stuff around like reactivity, and there's various virtual file system adapters that sort of store it on. You can have it in memory, you can store it on the file system with Node, or in the browser you have like IndexedDB or the Origin private file system. So there's a variety of different ways of having the kind of persistence for the embedded database. So it's, there's a whole bunch of good stuff in the docs here to dig into. I mean, maybe just to kind of show it, like this is Postgres running in the browser here using the REPL. So if I just go like select all from version, which is just a kind of built-in Postgres function, it tells you what it is, Postgres 16.4, compiled, etc. I can just do kind of normal stuff like create table, items, ID, UID, primary key. So that just creates an items table. Okay, that's just because I'd created one before. So create table items too, as you can see with the relation already existing. So the database behind this REPL is persistent in my browser. So when I've opened up in a new tab, the data is just available for me instantly because I'd already played around creating an items table. And so now if we go like items, it has the kind of like PSQL convenience commands here in the REPL. So you can basically see that there's like this is the table, and I could go insert into items, values into items. How do you write Postgres? I think gen random UUID. And then that'll just insert into the items. I can run this a few times, select all from items. Kind of here it is, right? So this is just obviously very basic kind of command line interaction with the database, but the point is that it is just fully featured Postgres just running in the browser for you. Like any data type that you can compile, that is either native or you can compile in through these extensions here on the right, is just available for you inside your application. And so to give another bit of a sense of what you can build with it, so there is this very nice database.build site now. It was called Postgres.new, but it's just been renamed. So this is an application that Supabase built. It's basically a fully featured AI tool to help you create a database-driven application on Postgres, and it runs purely inside the browser. And in fact, you can now connect to your in-browser Postgres just from PSQL locally. So it's this sort of database-driven application using AI that doesn't require you to spin up any server-side database infrastructure at all. So to just show you how it works, for example, what would you like to create? I would like to create a CRM system with kind of sales pipeline. I don't know, something that you might want to create. It has some cool stuff in here to then basically generate out like tables and a data model for you, and you can interact with the AI to sort of customize this. And I can go, yeah, it kind of generated. So I can go change that. Let's rename. Any suggestions? Ooze. Maybe I'm going to confuse it. Okay, it's now updated the model. Great. And this basically is creating these tables that you're seeing in this diagram. Like you can see the migrations here that have been run basically based on that conversation, and you can just build up the application. And then like build an example widget. So it's explaining what it's going to do. Here's your example query to get the data. Here's it giving you the HTML and the CSS to build the application, all basically based on your like model that you're building in the browser. And so, as I say, this is one of the examples of the type of application that you can build on PG Lite, which you can kind of see here. And then once you've built that in the browser, you're going to want to have different ways of potentially persisting that. And so you could persist out to blob storage, you could store to a durable object, or you could sync back into a database, like a hosted database from a company like Supabase or Neon.
Wow, this is very, very impressive. I mean, everything you showed us. Thank you so much for these walkthroughs. I have a few questions.
Yeah, not at all.
One would be, what about type safety? When we're fetching, like in TypeScript, is this supported?
Yeah, so one of the things in like the evolution of the project with Electric is, so we built a previous version of Electric, which was more of an integrated local first software stack. And in that, for example, yeah, we had things like a type safe data access library that was built off your data model. But what we found in reality is that if you think about like the role of a sync engine can sync into lots of different types of environments. It could be a JavaScript environment, it could be a different language like Swift, Kotlin, Elixir, you name it. And actually there's a lot of very cool projects. So things like Tinybase, which is like a reactive data store API. As I mentioned before, there's a very cool project called LiveStore, which is developing a very optimized kind of high performance reactive client side for like relational sync. And so what we stepped back from with Electric is like owning that kind of client side, because actually there's a lot of very cool projects which can kind of build this type of thing for you. And so like here, for example, here's like to do MVC using the Drizzle ORM with LiveStore and demos of running, but basically like there's a bunch of existing client libraries. So Electric doesn't mandate the client that you should use, and so therefore concerns like type safety are kind of up to you in terms of what system that you use. And there's lots of existing systems like Drizzle or Tinybase that you could use with Electric that do provide type safety and a kind of nice like ORM level experience when you're building your app. But they're all optional, right? It just depends kind of what you prefer to do when you sort of compose a local first stack.
That makes sense. That makes sense actually to let people bring in whatever they're using. And you mentioned something to the effect of like a generic sync engine that could work across languages and frameworks. I mean, that's something like that is far away in the future. It sounds quite challenging. How could that work?
Well, in a way, like what we did, and this was a bunch of insight that came from Kyle Matthews, who joined our team recently. So he was the founder of a platform called Gatsby, which was a kind of early like application deployment platform and sort of static site generator. And so through Gatsby, he had a lot of experience of how people were building apps leveraging CDN infrastructure for deployment. And so with his insight, we rethought our replication. Like previously with this previous version, we had like quite a complex custom WebSocket binary protocol. It's sort of what you'd expect with Sync because you think it should be that for sort of real-time data and to kind of optimize the payloads. But we just deliberately simplified down to an HTTP API where the very cool thing about just serving data with an HTTP API is it's accessible from any language. So every language can easily build a client for Electric in like maybe a day, just because it's simply a matter of just implementing some long polling kind of algorithm on top of a standardized HTTP API. But then also actually what's very nice is that it integrates with existing content delivery networks. So you sort of have two and then another is the sort of consuming kind of real-time feeds once you're kind of up to date with the data. And so with an HTTP API, you can just serve the initial data sync for shared data. Like in our case, like if two users are syncing the same shape, then one user loads it from Electric, but all subsequent users can just load it out of the CDN. And so you get this very fast, scalable content delivery of the replication data. And then imagine that you have like 100 clients and they're all consuming the same shape. When they're coming back to request data or request the live data, they basically send a standard HTTP request that then blocks waiting for new data. Now, the way that CDNs work is that they use something called request collapsing or request coalescing to basically turn all of those parallel requests just into the same API, into the same HTTP request. So again, you can just basically scale out effectively infinitely this kind of real-time content delivery, just because you're building it on this kind of standard HTTP primitive, which of course people have been building the kind of delivery tooling on for decades now. So it's really by sort of consolidating the replication protocol down on very, very simple standard primitives like HTTP and JSON that we've been able to sort of remake a sync engine that is just, you can just use it from pretty much anything. And actually it just scales out effectively infinitely out of the box so that you can have like 1 million concurrent users consuming real-time data on top of just a standard commodity Postgres, and there is no load on the Postgres database.
That is so cool. I'm very glad we did this deep dive. I found Electric on GitHub trending for Elixir, just posting up there like, every day, every week. Algora TV was there, also open source, built in Elixir, and that's where we found you. And you're like, what is ElectricSQL? This looks super cool. So I really appreciated this deep dive. And I guess we have to see what we can build with this because the use cases are very sexy. The last question that popped into my head, something that I'm trying to wrap my head around. So, like, what you just described, does it take care of like prioritizing the syncing? Like, how do you not have conflicts? That makes
Sorry, I
sense.
just lost the audio there. So I don't know if you dropped out or I have.
Can you hear me now? One moment. We're doing in and out. Let me change this. Sorry.
Hey.
Can you hear me now?
Yeah, got you.
Yeah, so let's change this. Yeah, my question was basically I'm trying to wrap my head around how like the synchronization works specifically. Like if there's a conflict, do you somehow prioritize? Um,
Mhm.
like say for example, there's two people and they're they have this local first um, linear, and they both make changes, right? And they both come online. How do you
Mhm.
consolidate that? Yeah.
Yeah, I got the question. So maybe let me just try replying, but you've just frozen again for me. Um,
We can hear you now.
so absolutely, like with sync, you kind of have two directions. Um, one of the thing is syncing the data like from, say, a central Postgres into a local device, and then the other one is syncing changes that you would make locally, either through a central service like Postgres or kind of like peer-to-peer sync out to other people. To a total order. If you write in Postgres, then that like resolves any sense challenges. Now, so at the moment, what we do with Electric is we're dealing with this read path sync, actually saying we talk to Postgres directly, and then we change the local data. There's very nice tools existing that we have in our example. Now, with like an optimistic mutation, it's much more like it tries to write to Postgres. If it's valid, which in the vast majority of cases are right, is, and it's not encrypted, and you can roll back those changes on the client. So you can build local first apps without engaging in the RTs and concurrencies. If you want to, for example, if you and so as Electric, actually, that's our sort of heritage as a project. So we were created in partnership with the academics who invented CRDTs. A lot of our team kind of specializes in that distributed systems world. But to try and make something that's actually usable as a product to build apps on today, we've kind of pushed all that complexity out of scope, because in reality, you don't need it to build local first apps. Come back next year, tooling for that kind of a sort of generic solution for that through the database sync. But actually, in a lot of applications, you sort of don't need to get stuck into that kind of rabbit hole in order to just actually make a really good user experience and a resilient application.
Awesome. Thank you for explaining this. And with adoption growing, an ecosystem will be built around Electric. So if it doesn't come from you guys, maybe it's gonna come from someone else in the ecosystem.
Yeah.
So now, just to switch sort of like the pace and time allowing, I would like to talk a little bit about the company ElectricSQL. This is a commercial open source endeavor. So it means you need to worry about sustainability, funding the organization, hiring a team, getting to market, increasing awareness. So how are you handling these things at a high level? And we can go into details maybe.
Yeah. I mean, so yeah, we're a VC-funded open source project, right? So in some respects, we've taken the red pill, and that's been very helpful at being able to kind of build a team and try and sort of crack problems. Like like everything is kind of fully open source, and all of the kind of core tech will remain so. The way that we plan to monetize is first by building out a cloud service, so hosted Electric, and then we hope to maybe, if you're an enterprise and you're sort of moving to this type of pattern for deploying software, there are tooling and capabilities and things that you will need, that we can provide those as a sort of addition to the kind of core sync technology. So that's sort of generally how we think around monetization. And we're fortunate to have very good investors who are happy to take a long view, and they understand kind of that it takes sort of time to go through the gears on that type of monetization strategy. And so everything for us at the um, and then basically the more people that we get doing that, the better we'll be able to make the software, and then we can sort of go through the gears on monetization.
That makes a lot of sense. It's a classic playbook. It's sensible, especially for this type of product. So we're definitely gonna be keeping tabs, and again, hopefully use it too, because I think there are some use cases that fit very well for us. That's very cool. What's on your plate right now? Do you travel? Are you based somewhere specific?
Yeah, well, I actually live in Croatia, so I'm kind of just south of Trieste on the Adriatic coast in sort of Central Europe.
Very nice.
And the team is kind of distributed, mainly spread out around Europe. We have Carl now, who's based in Salt Lake City in the US. We just did a couple of weeks in San Francisco. There was this great small data conference I mentioned. Carl was talking at Netlify Compose. And also kind of we get the team together every quarter, so we met up in Amsterdam. So yeah, it's a bunch of, basically for us, it's just very, very interesting to talk to people who are interested in this type of stuff that we're building. So there's a lot of just trying to kind of talk to teams who are building on Electric or are interested in potentially doing so, understand why they would want to, what it is that we would need to do to deliver value to this. So it's in a sense that sort of understanding users, and so that's sort of getting out building and talking to people, whether face to face or on Zoom.
Totally.
I mean, one thing I'd mention is that yeah, we have this cloud product coming soon. Interested in using that, that's something that you can just go to ElectricSQL. You can see the cloud product and just sign up from there. And we also have, so we have a Discord community. So I think there's about 1,500 developers in there now. And there's, it's an opportunity for people to just sort of talk through how to use Electric, but also people are collaborating on building some of the bits of the kind of ecosystem, as you say, that don't exist so far. And there's also some really nice like local first software communities. So, for instance, there's this lo-fi Discord, which is really cool. There's a bunch more people on there, and it's a place where people are discussing a lot of the projects in this space. And there's some really cool projects to dig into if you're sort of coming into this local first sync world. Like, I mean, this goes on. There's a lot of really cool stuff that's sort of being built where people are attacking different parts of the stack. And as you say, as a developer, you can then work out how to sort of compose different tools together for kind of what you would need for an application. But the whole sort of tooling is evolving very fast, and I think it's soon going to get to the point where to kind of engage with this sort of stuff, you don't have to be an expert in CRDTs and the complexities of the stack, but the kind of maturity of the tooling is really coming along to the point where things do work, and you can get the community benefit and the user experience benefits of sort of diving into it. So it's a nice timing, I think, to kind of dive into that landscape, and those are some great communities to kind of dig into.
Absolutely, and it's heating up. Why do you think that's the case? I mean, you mentioned Jazz,
Mm-hmm.
right? Just yesterday, they were on the Hacker News homepage, number one, and Anselm has actually been active on Algora recently. So, where does this recent fascination come from? Because I'm starting to see local
Mm-hmm.
first everywhere. Yeah.
Yeah, I think there's definitely these things where it's sort of now becoming possible. So yeah, like a lot of the kind of core challenges around concurrent are better understood. The is maturing. What you can do in the client has changed a lot, so that actually it's possible to sync data into clients and have this sort of reactive database experience. But also, I think you have things like Figma Linear. Like I know from talking to a lot of like startup founders or tech lead engineers that you know they just see a pattern. So once you've seen that pattern and what is possible to craft as user experience, it's very hard to unsee it. And so, what are you going to do? Go back to kind of wiring things up with a REST API and loading spinners? So, I think there's so many developers whose next project is going to be built on a sync architecture. And it's a bit like when we all sort of moved from manually updating the DOM to routing code that was handling network status errors, kind of now.
Exactly, that makes sense. Yeah, all these applications, they raise the bar for the user experience, and now we need to raise the bar on the DX for building these kind of experiences, and that's of course where Electric comes in. Amazing. What it's like working with Elixir? If you could tell us some things about this.
Yeah, I mean, I'm an Elixir developer. I sort of came out of like Python for a long time and Ruby and stuff, and shifted into Elixir, and just the whole sort of developer ergonomics around it have always been fantastic. It's a really supportive community. You have people like Jose, Chris, and stuff who are kind of leaders in the community who set a fantastic tone, and sort of stewarded the software in a really good way. And then the fundamentals of you develop on this Beam platform, and it has fantastic concurrency primitives. It's extremely resilient. It's functional, so you just don't have all these sort of problems of, like, in a sense, managing state is explicit. So it really helps you manage like simplicity of the application and helps with like refactoring. And it's and there's a lot of development in the community. So for me personally, I absolutely love it, and the idea of upping backend services in particular in some of the technology would be sort of, why on earth would I even think to? And for us, because we were doing this sort of like scalable concurrency and kind of like data piping, like actually there is a very, very good fit with like the concurrency and sort of data processing primitives available in Elixir. Things like dense stage, for example, and abstraction, piecing together pipelines, and then you have great architecture. So it's a fantastic fit. Electric kind of much faster than if we hopefully it's going to kind of, as we scale out, it's going to be a rock solid platform to actually push these kind of high data throughput volumes of data through. And we've also been looking recently at like Jose Villim, who created Elixir. He was exploring how to add this type of sync pattern into Phoenix, which is the main Elixir web framework. And so, he's another developer kind of seeing this sort of people's Phoenix applications.
Exactly, that makes tons of sense. Would make it the simplest for us to use. Not necessary, but that would make a lot of sense. I hope that happens. And of course, this ecosystem, the Elixir ecosystem, is also heating up. And I think projects like yours give the opportunity for more people to actually go check out the code base, familiarize themselves. And so I think it's only going to be increasing the adoption on both ends.
I think it's there's a lot of software craftspeople who sort of choose Elixir, right? So if you're a startup founder and things, and you actually care about the quality of your code and developer ergonomics, like Elixir is still a relatively niche language, but actually it's a lot of people who are actually building interesting projects are kind of choosing it for those. And then you've had things like Superbase was built in Elixir before, for example, and so there's sort of quite a lot of kind of qualities there. But
Of course, yeah, and then plausible. There's a lot of examples. So yeah, but they're only growing now. And Algora TV, the platform that we're streaming on right now. Would you have any piece of advice or any mistakes to avoid for founders, maybe commercial open source founders who are starting off? Yeah.
Yeah, I mean, kind of depends really.
Great.
I don't, where to start, right? I think, certainly one of the things that we've been trying to do is like build in public, just get the software out in people's hands and learn through what people are doing with it. I mean, we definitely, in a way, we had quite a, we did a legacy version of Electric I was showing you in the Electric today, was something that we explicitly chose to go specific mistake, I think, of kind of trying to bite off too much in the level of sort of guarantees and integrated experience that we were building. And it's been very successful complex systems built out of successful systems first and then iterated. To the sun, sort of the complexity we bit off Electric as a platform. So sort of finding a way to do something that is still valuable, much simpler, actually use. I think is what is very cool. With us, it's like right. Um, there's lots of stereotypes like in a space, they do back, they really do understand what you're doing. And so perhaps if you're in a situation where you're talking to investors who don't feel like that, sometimes it's just a matter of holding true to what you believe, actually getting through to the right people. Just taking well-intentioned advice early in the process with Electric was like, sort of, and like I remember, like almost a couple of years ago now, we like went to the US for the first time and we met some really good investors, and they were like, "This is the future of software." And so, actually, in some cases, particularly in this sort of open source software and dev tools, finding a way to get through to sophisticated investors who really do understand the space, and they allow you to execute the kind of operating plan that you really want to. Whereas certainly for us coming from Europe, a lot of the sort of standard mindset in Europe investors would be sort of enter early, get to kind of revenue fast, which would really undermine your ability to execute more of like a bottom-up kind of purer kind of developer tools approach. So we've been very fortunate throughout the journey that all of the investors that we've had on board have been fantastic and have really sort of understood and just helped shape the direction of the company. But sometimes you have to sort of fight your way through to the right people.
Makes a lot of sense. They exist certainly, and I'm glad that you found them, and you'll know when you find them. As you said, like you just, oh yeah, local first, we're following. Yeah, great. So let's continue the conversation.
I mean, the thing is they're watching you. Like, the level in the funding infrastructure, VCs are very, very good at just monitoring, like open source. You have all this open source intelligence, and they can see what's kind of spiking on GitHub, and they can evaluate, what developers are actually, the sort of quality of the engagement that you're getting from developers. So in a way, sometimes raising investment is not so much about going and kind of doing the legwork to talk to lots of investors and sort of try to sell them the investment. It's like do the stuff that makes you investable, and sort of believe me, they will come to you.
You already mentioned for distribution, the building in public definitely helps. We try to follow the same approach here. And then I guess on the company building side of things, if we could say something about hiring, how you approach this.
Yeah, well, we've been a remote work, if you're working intensively 5 days a week, you can burn out quite quickly. So actually deliberately having slightly better the longer run. You know, we like I can use Elixir Jobs Forum and sort of special places, and because yes, you can work anywhere. There was sort of a zone overlap. We were fortunate to be able to get good, experienced people to kind of come and work for the company. So, I mean, it's just for me, it's been a real privilege. I'm like the worst software developer on the team. Everybody on the team just brings a huge amount of value, and it's such a nice group of people to work with. And I think maybe just sort of trying to, by being able to create the right conditions for people to be able to sort of choose to join the project. You get to work in Elixir, you get to work on open source. It's very cool, interesting problems. It's 4 days a week. We pay reasonably good salaries. And you get to work on a kind of small technical team with other like-minded people.
Amazing. And we have
I think,
your jobs page behind us. So we're actually showing all this information. We saw that there is an open position. So Elixir folks that are listening in, I think hopefully we're going to get some interest here.
I mean, one of the dynamics generally I think about building companies like, like some early VC funding, and we've done like a couple of rounds now. It's definitely not to try to, there's not hire too fast. So, we were biting off some quite hard problems. We needed to build an engineering team. You sort of definitely go through these scales of an organization. And so at the moment, we're sort of deliberately staying at this sort of like 10 to 12 kind of people level where ultimately everybody does know everybody and you know what you're doing and you don't need sort of layers of management stuff. So all we startups, you're trying to avoid sort of startup theater and sort of unnecessary scaling and just do the actual thing to build the product for real. And so I think, one generic advice on hiring is just like, don't sort of try to scale the thing. To do get like about solving problems, work well together. Yeah.
And you put together a team of superstars, both the team members and the advisors and investors behind. So congratulations. There's actually someone from my hometown, Thessaloniki, that I see here, Stefanos Moussafiris.
Yeah.
That's very
Stefanos
cool.
is awesome. He spent 4 years as a CTO building an app called Savvy Navi, which was like a local first kind of sort of Google Maps for boats. So he joined with like 4 years of war stories of genuinely building local first, and he's totally awesome. Yeah. But yeah, I mean, we were sort of originally like a spin out from the Sorbonne, and because we had Mark and Nuno as two of the co-inventors of CRDTs, and also their collaborator Annette Bieniusa, like she works very closely with Martin Kleppmann, etc. So yes, I think there was an element of like the quality of those people being involved in the project helped convince some of the initial people to join. And then, for instance, we had like Jose Valim joined as an angel investor, and so like the opportunity to work with him as sort of part of the team. So it's very much it's been almost the sort of the quality of the people who've been around the kind of project and sort of stewarding it has allowed us to hire good people onto the core team, and now it's like the quality of the people on the core team is kind of attracting more people in.
I love it, and this is a great high note to sort of like land the plane, bring this to a closing. I'm curious before leaving if you have any joke for us. I saw that you like stand-up comedy, so do you have anything fresh in your mind?
Well, that's always the thing. Like, it's like you're talking about work intensively, and you get a context shift. Like, and so what do you do on the weekend? And I'm like, oh, I can't think at all for databases. I can say what's green and hairy and goes up and down.
What's green and hairy and goes up and down? What is it?
It's a gooseberry in an elevator.
Okay, maybe don't use this.
I'm a father of two, so I only have dad jokes, I'm afraid. Yeah.
That works for us. That was awesome. James, thank you so much for doing this session. I know we went over time. It's really good. I'm excited to publish all this content. Any last parting thoughts from you?
Look, thanks so much for having me on. And yeah, if you're interested in Electric, just definitely kind of dive in, say hi on the Discord community. And we're electric-sql.com, and there's links in there to the PG Lite project.
Phenomenal.